Welcome. Let's solve this question on shear. ABCD is a quadrilateral with coordinates A 21, B 32, C 34, and D 03. ABCD is mapped onto A prime, B prime, C prime, D prime under transformation T given by the shear with the x-axis invariant such that A prime is equals to 4, 1. A, determine the 2 by 2 transformation matrix representing T and hence determine the coordinates of B prime, C prime, and D prime. That is 4 marks. Part B, A prime, B prime, C prime, D prime is transformed to A double prime, B double prime, C double prime, D double prime under a transformation H such that A double prime is given by the coordinates -6, -9, and D double prime is given by the coordinates -12, -15. Determine the 2 by 2 matrix representing H and hence determine the coordinates of B double prime and C double prime. That is 3 marks. Part C, A double prime, B double prime, C double prime, D double prime is mapped onto A triple prime, B triple prime, C triple prime, D triple prime under a transformation V representing a reflection in the line y is equals to -x. Determine the 2 by 2 matrix representing V and hence determine the coordinates of A triple prime, B triple prime, C triple prime, D triple prime. That is the remarks. Let's go to the first part of the question where we are supposed to determine the 2 by 2 matrix representing T, and you're given that T is a shear with the x-axis invariant, and you're given the object point that is A 21 and the image that is A prime 41. That is what you're going to use. You're going to use that point A and its image. And one thing that you're supposed to know, for us to get the coordinates of B prime, C prime, and D prime under shear, we need to get the shear factor, and then from the shear factor we shall get the shear matrix. So how do we get the shear factor? The shear factor is given by this formula, which I want you to note. This is very important. So this is very important. So the shear factor is given by distance. You take any distance that you're given, that is from the object point to the image point, then you divide by the perpendicular distance from the invariant line to the object point. The object point. So as you can see, I've plotted that object A, B, C, D. So this is how you get the shear factor: distance from the object point to the image point, and you're going to use A since you're given A being 2, 1 is mapped onto A prime, that is 4, 1, and this one is a shear with the x-axis invariant, so it means the shear is parallel to the x-axis. That is why you can see, you need to be very keen. You notice that the y coordinate is not changing because this shear is moving parallel to the x-axis, so the y coordinate remains to be constant. That is what is going to happen for all the image point and this shear. So how do we get this distance? We need to plot these 4, 1. So 4, 1 is somewhere, this is here. So this is A prime. So it is here. 4, 1 is there. So distance from A to A prime. That distance is 1, 2. Just 2 units. 1, 2. That is 2 units. Then the perpendicular distance from the invariant line. The invariant line is there. You can see this is the x-axis. To the object point, So this is the distance this is the distance, the perpendicular distance. That is the distance. The perpendicular distance from the invariant line, this is the invariant line, the x-axis, to the object point. So that distance is 1 unit. So from the invariant line perpendicular to the object point, that is 1. So therefore, the shear factor is 2. That is how you get the shear factor. Upon getting the shear factor, we need now to get the shear matrix. And here, you need to understand the general format of the matrix representing the shear with the x-axis invariant, or shear parallel to the x-axis. And that shear is given by, so shear with the x-axis as the invariant line is given by 1k, very careful here, 1k 01. That is the general matrix representing a shear with the x-axis invariant, or the shear parallel to the x-axis. As you can see, we said that this shear is moving parallel to the x-axis. That is all you can see from A. Look at where it is moving, A to A prime. The movement is parallel to the x-axis. You can see that. Where K is the shear factor. K is the shear factor. So in this case, getting the shear matrix will be easy, since we already have the shear factor as 2. K is the shear factor and you got it as 2. So this one will be 1, 2, 0, 1. So this is the required matrix. So let's see whether we've answered the question. You're supposed to determine the 2 by 2 matrix representing T, and hence determine the coordinates. Now we have got it. So this is T. Now we need to get, because we only have, from these we only have the image of point A, we need to get all the others. So to get the image points of B, C, and D, you just need to take the shear matrix, already you have it here, and then pre-multiply with the object points. So you have B, so this is what you're going to do. So simply take the shear, which is the shear matrix, which is 1, 0, then 2, 2, 1, and then you need B, multiply this one with B, C, and D, like that. You need to pre-multiply, and then you shall get B prime, C prime, and D prime. Simple as that. So B is 3, 2. C is 3, 4. C is 3, 4. 3, 4. Then D is 0, 3. So you just pre-multiply. You take this one is a matrix T, the shear, then you pre-multiply. So you know how to pre-multiply this. So this is a row 1, column 1. So 1 times 2, this is a 3. 3 plus 4, that is 7. So then row 1, column 2, this is 1 times 3, this is 3. Plus 2 times 4, 3 plus 8, this will give 11. Then for D, 1 times 0, that is 0 plus 2 times 3, that will give 6. Then you go to row 2. So 0, this one will be easy. You just 0 times this one will be 1. We said that the y coordinates are not going to change, since the movement is, the invariant line is the x-axis and the movement is parallel to the x-axis. So it will be 1. When you pre-multiply this, you get, this one will be 4, this one will be 2. Sorry, this one will be 2. This one will be 4. This one will be 3. So therefore, the coordinates B prime will be 7, 2, then C prime 11, 4, and D prime will be 6, 3. So that is how you work out that question. Part B, A prime, B prime, C prime, D prime is transformed to A double prime, B double prime, C double prime, D double prime under a transformation H, such that A double prime is given as -6, -9, and D double prime -12, -15. Determine the 2 by 2 matrix representing H and hence determine the coordinates of B double prime and C double prime. Now that we have the coordinates of A prime, B prime, C prime, D prime, and we have also the coordinates of the corresponding image, that is A prime, A double prime, and D double prime, we shall use that to find matrix H. And this is what you're going to do. So we shall let H be represented by, so we let H be represented by matrix A, B, C, D. So our intention here is to find A, B, C, and D to give us that matrix. So when we take this matrix, that is A, B, C, and D, like that, and we multiply it with the object, which is A prime, B prime, C prime, and D prime, like that, we shall be able to get the corresponding image, that is A double prime, B double prime, C double prime, and D double prime, like that. So let us put the coordinates of A prime, B prime, C prime, D prime. We got this one in the first part. So this one was 4, 1. This one was 7, 2. This was 11, 4. And this was 6, 3. Then we are given A double prime and D double prime is given there, you can see. So we have this one as a -6, -9. And here we have -12, -15. So what we don't have is B double prime and C double prime. So we need to get this matrix. Once we get this matrix, it will be very possible to get now the coordinates of B double prime and C double prime. And we are going to use whatever we are given here, A double prime and D double prime. So this is how we multiply these. So we have row 1, column 1. We take this row, AB, multiply by this column. We shall get, that one will correspond to this element, -6. So this row times this column, A times 4, we get 4A. Plus this B times 1, that is B. That one will correspond to -6. Then from there, we need this also, -12. So that one we get it by taking row 1, multiply by this last column for D prime. That is what will give D double prime. So A times 6, that will give 6A. Plus B times 3, that will give 3B. And that one will correspond to -12. Now, you can see that I formed simultaneous equations. Now it is possible to find the values of A and B from these. So we can proceed. Then we will find C and D. So I will use the elimination method, whereby I want to eliminate B. So B, here we have B, here we have 3B. So I want to make B uniform. So I'll multiply this one by 3 to make it 3B. And when you multiply, you have to multiply everything. So 3 times 4, that is get 12. This will get 12A plus 3B is equals to -6. So the whole of this equation you multiplied by 3. Then this one you just multiplied by 1. So this will be 6A plus be 6A plus 3B is equals to -12. Just like that. So subtract to eliminate B. So 12A minus 6A, you get 6A. Then B will be eliminated. And here we have -6, subtract -12. Oh, this will give 18. I'm sorry. -6 times 3. I forgot that. Sorry for that. This one will give 18. I didn't multiply this. You have to multiply everything here by 3. Everything by 3. So this one was 6 times 3. This will give 18. So -18 subtract this is -18. So -18 subtract -12. This will give -6. So A will give -1. Simple as that. So once we get A as -1, now it is possible to get B. So to get B, you just need to take 4A plus B is equals to -6. Just take this one of the equations here and substitute. When A is -1, here you'll have, just substitute A is -1 in these. You get here -4 plus B is equals to, that one will give -6, like that. So therefore, B will be -2. So you have A and you have B. Now we can proceed and get now C and D. Let us get C and D. So to get C and D, this is what you're going to do. We want these element -9 and -15. So this one correspond. How do you get -9? So that one will correspond. This is A. So when I take this row 2, C times CD, multiply by this column 4, 1. So row 2, column 1. So C times 4, you get 4C. Then plus D times 1, you get D. That one corresponds to -9. Then this -15 here, we get it by taking row 2, the last column here. That we get this element here. So C times 6, you get 6C. Plus D times 3, you get 3D. That one should give -15. That one corresponds to -15. So again, let me eliminate D, and I want to make D uniform. So I'll multiply the whole of this equation by 3 to make these 3D and these on 3D. So multiply everything by 3, you get 12C plus 3D is equals to 27, -27. This will be -27. So this one will be 6C plus 3D is equals to -15. Then you can subtract to eliminate D. 12C minus 6C, you get 6C is equals to -27, subtract -15. This one will give -12. And C will be -2. Once you get C as -2, you can substitute this C in one of these equations. So let me take this 4C plus D is equals to -9. Taking this equation without multiplying it by 3. So substitute when C is -2, this will be -8 plus D is equals to -9. And D will be -1. Now we have C and you have D. So now you remember the matrix. The matrix was H. Matrix H was A, B, C, D. So and now we have the value of A. A is -1, just substitute. So this one will be -1, like that. Then B will be -2. Then C will be -2. And D will be -1. So that is matrix H. We've got matrix H. Now that we have matrix H, the question is find the coordinates of B double prime and C double prime. Remember, that is what we didn't have. So altogether, you just take the matrix that is -1, -2, and -2, -1. And because we want the matrix of B double prime, so we have to multiply this one by B prime and C prime. And this is what is going to give us B double prime and C double prime. As simple as that. So we already have B prime and C prime, 7, 2 and 11, 4. 7, 2 and 11, 4 is there. So 7, 2 and 11, 4. So we just multiply and get these. So row 1, column 1. So this is a -7. Need to be very keen here. So this row times this column, -1, this will be -7. -7, this is -4. Okay, -7, -4. So this will be -11 there. And then we go to row 1, column 2. So -1 times 11, that is -11. Then -2 times 4, that is -9. 8. This will give negative 19. So this one is negative 19. We go to row 2. For row 2 column 1, negative 2 times 7, that is negative 14. Negative 14 minus 2, that is negative 16. So this one is negative 16. Then the last one, row 2, the last column, negative 2 times 11, negative 22. Then negative 1 times 4, negative 4. So this will give negative 26. So this one is negative 26. So now we're supposed to answer the question, get the coordinates of B double prime. The coordinates are written in this form, negative 11, negative 16, and C double prime is negative 19 and negative 26. Part C, A double prime, B double prime, C double prime, D double prime is mapped onto A triple prime, B triple prime, C triple prime, D triple prime, and a transformation V representing reflection in the line y is equals to negative x. Determine the 2 by 2 matrix representing V, and hence determine the coordinates of A triple prime, B triple prime, C triple prime, and D triple prime. So this one, V is a matrix representing reflection in the line y is equals to negative x. And what is mapped? The second image you got, the third image. And we have the coordinates of the second image. We've just got it in the second part. You have it there. So one thing that we need to do is to start by getting the matrix V. How do we get the matrix V representing the reflection? This is how we get it. We are going to use the unit square to get that. So I will illustrate that on using the unit square. Unit square is very helpful. It helps you to get most of the matrices of transformation. So this is the x-axis, this is the y-axis. So 1 unit. So this is a 1 unit. So that this will be I. I will be 1, 0. Then we have j. This is a 0, this is a 1. So j will be here, will be 0, 1. So these 2 points, we call this one the unit square, because if we complete it, it is a square of 1 unit. So here we have k, which is 1, 1, but we only use I and j. We normally use I and j, that is 1, 0, and j 0, 1 to get the matrix. We draw the line y is equals to negative x. Y is equals to negative x is this line. Let me draw it. This line that passes through the center of the axis here, that is the line. This is the line y is equals to negative x. If this one is a reflection, you know how a reflection is done. So I will be reflected here. It will be directly opposite, this one being the mirror line, y is equals to negative x. So I will be reflected directly opposite side here. So this will be negative 1. So this is the image of I, that is I prime. This will be 0, negative 1. Then for j, j will be reflected directly here by this mirror line. This one is a mirror line, y is equals to negative x. So it will be here, and this will be j prime, the image of j. It will be negative 1. This will be negative 1, negative 1, 0. So I'd like you to observe, under reflection in the line y is equals to negative x, point I, which is 1, 0, is reflected here. You know that under reflection, the object, this distance between the object and the mirror line, and the mirror line to the image, this distance is supposed to be the same, equidistant. The object and the image are equidistant from the mirror line. So this one is reflected here, this one is reflected here. So let me write it down. Yeah. So I, which is 1, 0, is reflected to I prime, which is 0, negative 1. J 01 is reflected to J prime, which is -1, 0. Using this image, we can come up with a matrix representing the reflection in the line y is equals to -x using the image. So this is how we get the matrix, by just organizing I 0, -1, 0, -1. Simple as this. 0, -1. And J -1, 0, -1, 0. That is how we get the matrix. The easiest way to get the matrix of transformation representing reflection. That is how we do it. So this one is the matrix representing reflection in the line y is equals to -x. So 0, -1 is here. This one J -1, 0. We use the image points. Having now the matrix, we can now simply get the image. So now we have the matrix V. So this is matrix V. That is matrix V. Now that we have that, we just need to take the matrix and multiply that one with. So we have 0, -1, -1, 0. And since we have the coordinates of A double prime, B double prime, C double prime, D double prime, we just write them down. So we have -6. So we have A double prime, B double prime, C double prime, and D double prime, like that. This one should give A triple prime, B triple prime, C triple prime, and D triple prime, like that. So we have these from the other part B. So -6, -9, -11, -16, -19, -26. Then this one was -12, -15. So we just need to pre-multiply these. So row 1, column 1. You know how to multiply these, so it is not a big issue. So row 1, column 1, this one will give 9. This one will give, I'll fill the first row first, 9. This will be 16. This will be 26. This one will be 15. Let me go to row 2, column 1, like that. Then row 2, column 3, column 2, and so on. This will give 9. So this will give 6. This will give 11. This will give 19. This will give 12 when you multiply. And there's something that you notice about reflection in the line y is equals to -x. Look at the object point and the image point. Like for example, A double prime and A triple prime. -6, -9, 9, and 6. You notice that under this reflection, the object points are interchanged and they also change the signs. Both the x and the y coordinates, they interchange and they change the signs. So we can conclude that under a reflection in the line y is equals to -x, a point, say AB, under y is equals to -x, the image will be given by the points are interchanged, that is will be -b and -a. They get interchanged and they change the signs. So now the question was find the coordinates. We need to write the coordinates. These are not the coordinates. So the coordinates are supposed to be put in this way. A triple prime is 9, 6, like that. Then B triple prime is supposed to be 16, 11. Then C triple prime is supposed to be 26, 19. And lastly, D double prime is supposed to be 15, 12. That is how you're supposed to solve that question.